Hello everyone, myself Pancham Singh. I am going to discuss one of the most important topic of cryptography network security, that is Euler's phi function and Chinese remainder theorem. So in this lecture I will discuss about the numerical part. Earlier I have discussed about the theoretical part, but this is the important lecture for the numerical purpose, because many times students they are stuck in the numerical part and they are not able to solve the numerical section. So in this section I will discuss about the numerical part. So first I am going to discuss about what is the Euler phi function. So Euler phi function is represented by the phi n, that is the phi n, which is sometimes called the Euler's totient function. So sometimes it is also known as the Euler totient function, play a very important role in cryptography network security. So how you will calculate the Euler phi function in the numerical section? So first I will calculate the phi 1. So phi 1 can be represented by phi 1 equals to 0. Similarly, you are going to calculate the second part, the second section, that is phi p. So p is the prime number, relatively prime number, that is p minus. So phi p equals to p minus 1, where p is the prime number. And third part, if you are going to calculate the phi m into n, which is equals to phi m into phi n. So where m and n are relatively prime number. So m and n are both are prime number, and by help of the two different prime numbers you can calculate the phi m into n. Now last one is that is fourth part. So in phi p to power e, which is equals to p raised to power e minus p raised to power e minus 1, where p is a prime number. So prime number, with the help of the prime number you can calculate the value of phi p to power e. Similarly, with the help of the value of phi m into n, where you can calculate phi m into phi n, where m and n are relatively prime numbers. So if you're going to combine the above formula, above four rules to find the value of phi n, so you can write the value of n. So it is written in this form. So where n equals to e raised to power e1 into p2 e raised to power e2 into up to dot dot pk raised to power ek. So with the help of the phi n, previous four part of the phi n, so with the help of the four above rules we can calculate the value of n. So the value of n is dependent upon the prime value, that is p1. Similarly, it is dependent upon the p2 up to dot dot pk. So basically, if you are going to discuss about the phi n, so phi n you can represent in this form. So if you can expand the value of the phi n, let's say p e raised to power e, we can write down p1 e to power p1 raised to power e1 minus p1 raised to power e1 minus 1. So you can put the value of p1 by p1 e raised to power e1 minus p1 e raised to power e1 minus 1. Similarly, in the place of the value p2 e raised to power 2, you can put the value of p2 e raised to power e2 minus p2 e raised to power 1. Similarly, you can multiply the last term, that is pk. So pk you can write the pk equals to ek power pk is e raised to power ek minus pk is raised to power ek minus 1. So how you are getting this value? You can see the previous slide. In the previous slide, you can get the rule 4. With the help of the rule 4, you can get the value of phi n in this form. So phi n basically is getting the previous rule 4. So that is equals to p1 is e raised to power e1 and minus p1 e raised to power e1 minus 1 up to dot dot. So the difficulty is of finding phi n depend upon the difficulty of finding the factorization of n. So the main problem is that if you're going to solve the phi n, so phi n can be solved by the help of the factorization of value of n. So if you are going to factorize the value of n, so definitely we can easily solve the value of phi n. Now we can go and solve the numerical problem. So with the help of the numerical section, we can easily solve the problem of the phi n. So what is the value of phi 13? So you can see the solution is that the prime 13 is a prime number. So you can easily solve the value of phi 13 equals to 13 minus 1. So you can say phi p equals to p minus 1. So by using the formula phi p equals to p minus 1. So this is the formula. By using this formula, you can solve the value of phi 13, where 13 is the prime number. So what is the value of phi 10? Because 10 is not a relatively prime number. So first you will convert the 10 into prime number. So what is the prime number of 10? You can factorize 10 into two different parts, 2 into 5. So where 2 and 5 are both prime number, so you can easily solve the value of phi 10. So we can use the third rule, that is the phi 10 equals to phi 2 into 5. So phi 2 equals to p minus 1 by using the phi p equals to p minus 1. Similarly, phi 2 equals to 2 minus 1. So you are getting the value of 1. Phi 5 equals to 5 minus 1. Then you are getting the value of 4. By multiplying 1 and 4, you are getting the answer 4. So 4 is the final answer. So by using the two different prime number of factor of 10, then you can get the value of phi 10. Now, if you are going to solve the value of phi 240, so how you can solve the value of 240? So first you will factorize the 240 by using the prime numbers. The prime numbers is 2, 3 and 5. So you can simply factorize the 240 like 240 here. So by 240 you can 120, and similarly 240 again you are going to 60. 240 again you are going to factorize 30, and 30 is not divisible by 2. It is divisible by 2. Then you can go factorize again. So we are getting the 15, and 15 is not divided by 2 because 2 is an even number and 15 is a odd number. So by using the next prime number, that is 3, we can divide it 15 and you are getting the value 5. And 5 is not divisible by the 3, then you can divide the next prime number, that is 5. So by factorizing the 240 in the last value, you are getting it is divided by 5 and you are getting the 1. So what are the values here? So you can get the value of how many values of 2 is there. So 2 power 4 into 3 k power 1 into 5 k power 1. So you are getting this is the final answer. So by 2, you are going to counting the value of 2, 1, 2, 3, 4. So here 2 k power 4. Similarly, 3 is occurring 1 time, then you are taking the value of 3 is 1. 5 is occurring 1 time, you are getting the value of 5 equals to 1. So after factorizing the 240 into 3 different prime numbers, then you can apply the formula. So you can get the value of 240 here. So 2 k power 4 into 3 k power 1 into 5 k power 1. By using this prime factorized formula, then you can convert in this form. And this is the rule 4. This is the rule 4 where you can convert pk power 4 minus pk power 2k power 4 2k power 4 minus 2k power 4 minus 1. So you are getting this answer. Similarly, you can getting the answer 3k power 1. So 3k power p minus 3k power p minus 1. So you can get this answer. Similarly, you can get this one, and similarly get this one. So you can get this answer by using in the previous formula. You can see here by using this p1 ek power 1 minus p1 ek power n minus 1. So by using this formula, you can easily calculate the value of 2k power 4, 3k power 1 and 5k power 1. So you can see the answer. This is the answer basically by using 2k power 4, 2k power 4 minus 2k power 4 minus 1, and similarly 3k power 1 minus 3k power 1 minus 1 and 5 power 1 minus 5 power 1 minus 1. So you are getting this answer. After multiplying the value, you are getting the answer equals to 64. So you can not directly solve the problem of phi 240. So first you will convert the 240 in the form of the prime factorize. Yeah, you can say you can convert the value 240 in the form of the prime numbers. After multiplying prime numbers, then you are getting the value of 240. Now in example 4, the example 4 is there, how you can say that 549 equals to 57 into 57. So is this answer is correct? Question is this answer is correct? So actually this answer is not correct. By using the next formula, the third rule applies when m and n are relatively prime number, then 49 equals to 7 raised to power 2. We need to use the fourth rule, that is 549 equals to 7 raised to power 2 minus 7 raised to power 2 minus 1. So by using this formula, rule 4, you are getting the answer 42. So 42 is the correct answer, but in case of 57 into 57, you are getting 36. 37 is not a correct answer. So by using the rule 4, you will get the correct answer. Now, what is the number of element in 514? So in number 514, you can convert the 514 in two different prime numbers, like 7 and 2. And 7 and 2 are two different prime numbers. So 7, you can write 57 equals to 7 minus 1, and similarly 52 equals to 2 minus 1. So you are getting the two answer 6 and 1, and 6 and 1 you are getting the answer. By multiplying 6 and 1, you are getting answer equals to 6. The numbers are 1, 3, 5, 9, 11, 13. So what is the number of elements in the Z14? So you can say that the number of elements in Z14 is 1, 3, 5, 9, 11 and 13. So how many numbers are there? You can count 1, 2, 3, 4, 5, 6. So there are total numbers, 6 numbers are there in counting of Z14. So you can calculate the value of n. Then on the basis of that, you can justify that how many numbers will occur in Z14. So total 6 number is occur. So Fermat's little theorem. In Fermat's little theorem, you can see the first version, that is written by the a raised to power p minus 1 equals to 1 mod p. In second version, a raised to power p equals to 1 mod p. So there are two different formula you can use in Fermat little theorem. So if you are going to solve the numerical problem, so find the result of 6 power 10 mod 11. So how you can solve the value of 6 power 10 mod 11? So we have 6 power 10 mod 11 equals to 1. So the answer is 6 power 10 mod 11 equals to 1. This is the first version of the Fermat little theorem where p equals to 11. So if mod p, if 6 power 10 mod p equals to 1, it means that the value of 6 power 10 mod 11 equals to 1. Now, in second question, you can solve the value of 3 raised to power 12 mod 11. So 3 raised to power 12 mod 11 you can write down, because the value of 12 is bigger than the value of 11. So we will convert the value of 12 in respect of 11. So you will convert the value of 3 to the power 12 mod 11. So value of 3 raised to power 12 mod 11 you can write down in this formula, 3 to the power 11 into 3. So you will mod 11. So by 3 to the power 11 mod 11, 3 to the power 3 mod 11. So you are going to split the 3 raised to power 11 into 3. Mod 11 can be written in the form of 3 to the power 11 mod 11 and 3 mod 11. So by using 3 to the power 11 mod 11, you are getting the answer is 3. And similarly, by using the 3 mod 11, you are getting the answer is 3. So in both situations, in both cases, you are getting the answer 3, 3. So answer is 3 into 3. Then you are getting the final answer is 9. So by using the 3 raised to power 12 mod 11, we are getting the answer 9. By using the 6 power 10 mod 11, we are getting the answer is 1. So in this question, it is very clearly explained. So how you can calculate the value of 3 raised to power 12 mod 11 and 6 raised to power 10 mod 11. Now multiplicative inverse. What are the multiplicative inverse? In multiplicative inverse, you can write the formula a raised to power minus 1 mod p, which is equals to a raised to power p minus 2 mod p. So how you will calculate the value of a raised to power minus 1 mod p and equals to a raised to power p minus 2 mod p. So you can calculate in different way. You can solve the numerical problem. In the first part, 8 raised to power minus 1 mod 17 equals to, you can write down in the second form, that is multiplicative inverse, that is 8 raised to power 17 minus 2 mod 17, and which is equals to 8 raised to power 15 mod 17, and we are getting the answer 15 mod 17. That is the 15 mod 17 is the final answer. You are getting the 15. In second part, 5 raised to power minus 1 mod 23, you can write down, and in the second way, like if 5 raised to power 23 minus 2 mod 23, we are getting 5 raised to power 21 mod 23, and the answer is 14 mod 23, and 14 mod 23, you are getting the answer is equal to 14. So by using these multiplicative inverse formula, you can solve the answer. What are the Euler's theorem? First version Euler's theorem is a raised to power phi n, which is equals to 1 mod n. Second version of Euler's theorem equals to a raised to power k into phi n plus 1, which is equals to a mod n. So there are two different formula of Euler's theorem which you can use to solve the numerical problem. So in the first example, find the result of 6 raised to power 24 mod 35. So in this numerical section, we can solve by using the inverse formula, like we have 6 power 24 mod 35, which equals to 6 raised to power 535 mod 35, and we are getting the answer equals to 1. So in the similar case, we are getting the answer 1. Like in the previous example, 3 raised to power 11 mod 11, we are getting the answer is 1. Now in next example, find the result of 20 raised to power 62 mod 77. So by using the formula, you can also solve this question and you can get the answer. The answer is 15, and 20 raised to power 62 mod 77, and you can convert into the two different mod, 20 mod 77 into 20 mod power 577 plus 1 mod 77. So by using this formula, you can get the value. That is, in the first case, we are getting the answer 20, and second case, we are getting the answer 20. So 20 into 20 multiply and mod 77, you are getting the answer 50. So multiplicative inverse, by using multiplicative inverse in Euler's theorem, you can solve the numerical problem. So this is the formula, a raised to power minus 1 mod n, which is equals to a raised to power phi n minus 1 mod n. So this is the formula of multiplicative inverse by Euler's theorem. So you can solve another example by using this formula. You can see here, 8 raised to power minus 1 mod 77. So you can write down in this form, 8 raised to power phi 77 minus 1 mod 77. So what are the answer? So you can get the answer 8 raised to power 59 mod 77. So 8 to the power 59, you can write down, which is equals to 29 mod 77. So this is the first answer by using the multiplicative inverse formula of Euler's theorem. So you can solve the next question, B section, also by using the same formula, and you can get the answer. So now I am going to discuss one of the most important numerical section, that is Chinese remainder theorem. So what are the Chinese remainder theorem basically? So in Chinese remainder theorem, we are going to solve the numerical problem of Chinese remainder theorem by calculating the value of x. So what is the x? X equals to a1 mod m1, and x equals to a2 mod m2, and x equals to up to ak mod m. So mk. So by using the Chinese remainder theorem, you can calculate the value of x. So value of x is same for the all different value of A1, M1, A2, M2 and AK, M1. So it is simple way if you are going to explain the numerical section. So first you will explain the numerical problem, then you can get the clear answer. So how you will going to solve the value of x? The following is an example of set of equation with different module. So x equals to 2 mod 3. So here a equals to, or you can say a1 equals to 2, m1 equals to 3. X equals to 3 mod 5. Here a2 equals to 3 and m2 equals to 5. X equals to 2 mod 7. Here a3 equals to 2 and m3 equals to 7. So these are the value where you can calculate, find out the a1, a2, a3. Similarly, you can find out the m1, m2, m3. So we are going to explain the next part. So how you are going to calculate the value of x. So if you are going to solve the Chinese remainder theorem, so first you will read the 4 important points. So these are the 4 important points. By using the point 1, that is we are going to solve the value of m. So m equals to m1 into m2 into up to dot dot mk. This is the common modulus. So where m1, m2, m3 up to dot dot mk, multiplying all moduli, we are getting the m, and that is the common modulus. Now in second part, we are going to calculate the value of m1. So m1 equals to m divided by m1, m2 equals to m divided by m2, mk equals to m divided by mk. So by using the value of m and value of m1, you can calculate m1. By using the value of m and m2, you are going to calculate the value of m2. So and so on. In the third point, if you are going to find out the multiplicative inverse of m1, m2 and mk, and it is very important. So if you are going to solve the value of m1, m2, mk using the corresponding moduli m1, m2 up to dot dot mk, call the inverse m1, m2, mk. So by using the m1, m2 and mk, with the help of the m1, m2 and m3 and so on mk, you can calculate the value of m1 inverse, m2 inverse and up to dot dot mk inverse. In the fourth point, that is the last point, where you can get the exact solution of the value of x. So what is the x? X is basically, it is a multiplication of a1, m1 into m1 square, m1 inverse, a2, m2 into m2 inverse up to dot dot ak mk into mk inverse. So value of x you can calculate by using the multiplication of these values. So now I am going to solve the numerical section first. So by using the numerical section, it is very clearly explain the value of a1, a2, a3, m1, m2, m3. So this is the equation. Basically, by using this equation, you can calculate the value of a1, a2, a3, m1, m2 and m3. So this is the a1. A1 equals to 2, a2 equals to 3 and a3 equals to 2. Similarly, the value of m1 equals to 3, m2 equals to 5 and m3 equals to 7. So these are the value. This is the moduli. You can calculate the value of a1, a2, a3. So these are the values are given in the equation. By using these values, you can solve the question. So the first answer is, what is the m? So m is equals to m1 into m2 into m3. So m1, m2 and m3 are given. The equation you can simply multiply, then you can solve the value of m. By the second part, if you are going to calculate the value of m1, so m1 equals to m1 equals to m divided by m1. So m is 105, m1 equals to 3. So you can calculate the value of m1. Similarly, m2 equals to m equals to 105, divided by M2, you are getting the value of M2. M3 equals to M divided by M3, you are getting the value of M3. So in the second section, you can easily calculate the value of M1, M2, M3 and so on. Now in the third section, if you are going to calculate the value of M1 inverse, so M1 inverse can be calculated. M1 inverse can be calculated by using the value of M1 and M. So here is the value of 35 is given. And what is the value of M1? Equals to 3. So 3 mod M1 equals to M1 inverse. So if you are going to calculate the value of M1 inverse equals to M1 mod M1. So by using this formula, you can solve the value of M1 inverse. So M1 inverse equals to M1 mod M1. So what is the M1? M1 equals to 35. What is the value of M1 equals to 3? So by using this formula, you can solve the value of M1. Similarly, by using the M2 inverse equals to M2 mod M2, you can get the value of this. So by using this formula, you can solve M1 inverse, M2 inverse and M3 inverse. And after putting the value of all, you are getting the value of X. So X is equals to basically 23 mod 105. This is the answer. So by using Chinese remainder theorem, you can calculate the value of M first. Then after you can calculate the value of M1. And in third section, you can calculate the value of M1 inverse. And last section, you can calculate the value of X by putting the value of E1, M1, M1 inverse. And similarly, in this section, you can also solve the numerical section by using this equation where the value of A1, A2, A3 are given, M1, M2, and M3 are given. You can solve that. Similarly, these are the equations are given. By using this equation, you can also solve the value of M1, M2, M3, and similarly value of A1, A2, A3. So there are two different equations. So you can sum up the equation by using Z equals to X plus Y. So by adding two equations, you can get the value of Z equals to 61 mod 99, similarly 65 mod 98 and 69 mod 97. So by using adding two different equations, you can get the value of A1, A2, A3 and M1, A2, A3.